Returning to Chapter 2, we're going to compare the mean and the median. If we have a symmetric distribution, the mean and the median will have very similar values. If there's a skewed distribution, the mean is going to be further out in the long tail. So if you have a left skewed distribution, the mean is going to go further left, so it's going to be smaller than the median. If you have a right skewed distribution, the mean will be greater than the median. Again, the mean is going to follow where the long tail is. The next slide will illustrate this. As you can see in this first graph, we have a left skewed distribution. And as I just said, the mean follows that long tail. So the mean is going to have a smaller value than the median. The middle one is a symmetric distribution where you see the mean and median equaling one another. And the mode, we haven't discussed the mode. The mode is the data value that occurs most often. And in this symmetric distribution, all three of these measures of central tendency will be approximately the same. In a right skewed distribution, the mean will follow the tail, the long tail, which is going toward the right. So the mean will take on values longer than the median. So what we find is that the median is a resistant statistic, but the mean is not. And let's see why. Let's look at this data, this example 612. If there was a recording error and we took the mean of this data, we'd get a mean of 2001 when it should have been 3. Sorry, it took me a little bit. So, but the median remains the same. The median remains 2. So what we find out is that the median is a resistant measure, whereas the mean is not resistant. So when the data has extreme values or the distribution is skewed, the median would be the preferred way to get this typical value or the measure of central tendency. Whereas with the symmetric distribution, the mean is the better way to calculate the measure of central tendency. So here's our summary. If we have roughly symmetric data, the mean is our best choice for the measure of central tendency. It's the center of gravity. However, if we have highly skewed data or data that has extreme values, our mean is our better measurement for central tendency. Now here's a question. A recent newspaper article in California said that the median price of single-family homes sold in the past year in the local area was $136,000, and the mean price was $149,160. Which do you think is the more useful to someone considering the purchase of a home, the median or the mean? And I would like you guys to go to the discussion board and post what you think would be the more useful for someone considering to purchase a home. So now we're going to talk about the spread or the variability of our data. If all the values are the same, then they all would be equal to the mean, and there would be no variability. However, variability exists when some of the values are different from the mean, which is generally what happens. Now, the numerical values that represent the degree to which the values are spread out, or variability, the ones that we're going to study in this chapter are the range, the quartiles. That's the first quartile, or the 25th percentile, the second quartile, or the 50th percentile, or the third quartile, the 75th percentile. Those are the different quartiles. There's also the variance and standard deviation. All of these are measures of measuring the spread. So let's take a look at this range. Now we talked about the range when we were doing cut point command. So we should know what the range is. It's our maximum value minus our minimum value. That's how we calculate the range. So if we have example 6 that we see here, we first put it in order to find our minimum and our maximum value. And so our largest value is 11 and our smallest value is 1. So the range would be 11 minus 1, or 10. Now since this is a sample, we would go one more decimal place than our data has, so we would say the range is 10.0. So we're going to pull up Minitab and see how we use Minitab to find the range. And here's the command for range. You see right there the MTB prompt, and we just write range. But remember, I could use just the first 4 letters of my command, and Minitab will know what it is. So let's look at Minitab. So we're going to go into Minitab, and we're going to say, hey, I want to do the range. And let's say we want to do the one that we were, let's do example 4. So we'd say we want the range of C5, because example 4 is in column 5. When I do that, I see my output as 10. Now, since example 4, everything goes to the units digit, my answer for the range for that sample would be 10.0. So let's look at what the range of C6 is. That's example 5. The range there is 22. So that's how we use Minitab to find the range. Now the range is not resistant. Look what happens with the same example. If we had 6,000, we put 6,000 instead of 6. We would now have a range of 5,999 instead of 5. So that's quite a bit of difference there. So the range is not resistant. So let's